Example 1. A particle moves in a straight line with displacement from O, the origin, given by S of t equals 3t subtract t square meters at time t seconds. Okay, so distance is in meters, displacement is in meters, time is in seconds. Find the average velocity from time interval 2 seconds and 5 seconds. So we're talking average velocity here. That means we're not looking at the derivative. We're talking about average velocity. If our displacement curve was something like this, and t is 2 seconds here, t is 5 seconds here, the average velocity is the chord that joins those two points together. So let's figure out what the y-coordinates of those points are. So the function is S of t equals 3t subtract t squared. So we're looking at what's S of 2. Substitute 2 in here. And that is 2. That's displacement, so 2 meters. So that means this point is 2, 2. And S of 5 is 3 times 5 subtract 5 squared. So 15 minus 25 minus 10. Okay, so displacement, remember, can be negative. It means that we're on the left-hand side of the origin. So if we look at average velocity, that's going to be equal to S of t2 subtract S of t1. You don't have to do it formally like this if you don't want to. You can just take this second value, y value, and first y value, divide it by t2 minus t1. So negative 10 subtract 2 over 5 subtract 2, which is negative 12 over 3, which is negative 4. And our units are meters per second, or ms negative 1. Part B. Find the average velocity for the time interval 2 seconds and 2 plus h seconds. So what's S of 2 plus h? Well, that's 3 times 2 plus h. Subtract 2 plus h squared. 6 plus 3h. Subtract 4 plus 4h plus h squared. Distribute that negative sign through the bracket. And it's negative h squared, collecting our like terms. Subtract h plus 2. That means that the average velocity S of t2 subtract S of t1, divide it by t2 subtract t1. So S of t2, that's this value. Subtract S of t1. Well, that was S of 2, which is up here, which is 2. All over. T2 was 2 plus h, and T1 was 2. So we're looking at negative h squared subtract h plus 2 subtract 2 because it's 0. 2 subtract 2 is 0. There's an h there. All over h. Factor out a negative h here, so h plus 1 all over h. So negative h plus 1, or negative h subtract 1. And this is meters per second. Keeping in mind that h could not equal 0 because there is an h in our denominator here before we simplified. Part C, the limit as h approaches 0. Okay, we just calculated this limit up here. So negative h plus 1 as, sorry, I should write that as still the limit as h approaches 0. We've already done this work in part B, so I'll just write it down, negative h plus 1. So as h approaches 0 there, this would be equal to negative 1. And that is meters per second. What this is, what it indicates, the significance of it is, it's the instantaneous velocity at 2 seconds, at that exact moment in time.